Thank you all for joining us today. This is the final event before the award ceremony for the KidWind Challenge. So we appreciate those who are participating in the KidWind Challenge to stick around and listen to this panel and learn a little bit more about wind energy. We've also opened this session up to the public for anyone who wants to gain more knowledge about wind energy and the impact to the surrounding community. My name is Scott Williams. I'm a co-organizer of the KidWind Challenge. I'm also the research and education coordinator at the Wisconsin Energy Institute at UW-Madison. And my role is working in energy education for students on campus, both at the undergraduate level and graduate level. I've been working for over 10 years at the Wisconsin Energy Institute. And in 2015, I first got involved in the collegiate wind competition, which if any of you joined for our noon session with the KidWind Challenge, you heard from some of our students with Wisconsin, which is the collegiate wind team. And by getting involved in that, in the collegiate wind competition, I became much more attuned to siting issues around wind energy. Wind energy is definitely a growing field. It started from a kind of a small base, a few decades ago, but it's becoming much more mainstream. And over the years, as new wind farms would be proposed in Wisconsin, I'd hear a lot of the same concerns about the impact of wind power on the surrounding community and the surrounding environment. And because wind energy is still somewhat rare in Wisconsin relative to our neighboring states, I think there are many who may be less familiar with this technology. And with that unfamiliarity comes with an opportunity for maybe some misconceptions to develop, especially when a new wind farm is being proposed to be built in a community. So our goal with this session here today in Wind Energy Fact Check is to talk with a panel of experts from UW-Madison and the State Department of Health Services to address some common concerns about wind energy and discuss what we know about wind energy's impacts to the environment, to public health, and to the economy based on the best evidence that we have available. So a little more background before turning over to our panelists. Just some facts about wind energy. It's now one of the cheapest sources of new electricity in this country, and it represents over 7% of our electricity mix in the US. And that's up from just 2% just a decade ago. So it's tripled in size over the last 10 years. And in some states, like neighboring Iowa, wind now represents over 40% of electricity generation. So as wind energy expands, it's seen as a major player in efforts to reduce greenhouse gases and reduce air pollution and mitigate climate change. However, there's no question that wind farms represent a major change in places where it's built. And due to the characteristics of wind turbines and the wind resource, that essentially means changes to rural landscapes. And it's natural for people to have concerns about what that change would mean for their community before deciding whether to accept a wind farm in their community. And so my hope with this conversation is to put the facts up front, and so that if there is a wind farm being proposed in your community, you can have an honest discussion about wind energy and what it can mean for your community. So we'll start with some brief introductory remarks from each panelist. I've got a few starter questions as well, and then we'll open it up to questions from you all. You can submit your questions anytime in the Q&A box, and I'll be monitoring those questions and direct them to the panelists at the appropriate time. We do have captioning turned on to make this webinar more accessible. If you prefer to turn that off, you can do so in your settings. So to kick things off from our panel, we have Professor Jim Tinjum. He's an associate professor of civil and environmental engineering at UW-Madison. His research and teaching involves energy geotechnics, which involves things like wind energy site design and construction, evaluation of geothermal heating and cooling systems. He's also interested in the beneficial reuse of industrial byproducts and life cycle environmental analysis of geological systems, remediation of contaminated sites, and heat transfer in soil and rock for geothermal systems. So welcome, Jim.
Well, thank you, Scott, and thank you for the quick introduction. I have I believe, a very enviable job that I get to teach college students how to develop, design, and construct wind energy sites. So a lot of my students are out there, possibly in your communities, thinking about developing wind energy. And Just one last thing that I want to get out there as an introduction is that I have visited every single large wind energy site in Wisconsin on my bike. So I have biked to every single wind farm in Wisconsin. So I've seen them. I've been to everywhere from Darlington up and down the Fox River Valley, up into the Door County Peninsula and around, so I can appreciate what wind energy looks like on the landscape of Wisconsin. But I'm also very excited to be able to teach students how to responsibly design and build these so that the impacts are minimal to our communities. So thanks, Scott, for having me.
Great. Thanks, Jim. Next, I'll turn it over to Mark Werner. He's the director of the Bureau of Environmental and Occupational Health at the Wisconsin Department of Health Services. He served at DHS for 23 years. He's also an adjunct associate professor of population health sciences at UW-Madison and adjunct faculty at UW-Milwaukee, and is often a go-to person when it comes to health questions around wind energy.
Thanks, Scott. I guess I would start by saying that we at the health department in my shop, in environmental and occupational health group, we spend a lot of time on lots of issues related to energy. So we have our staff inspect the nuclear plant, up the one that's still running in Wisconsin, at Point Beach. And we also do monitoring at other sites where there are other nuclear plants that have been decommissioned across the state. We get involved in some cases when there are pipeline spills, or providing advice if there is, say, an underground storage tank that leaks at a gas station, helping the community or local health department or the Department of Natural Resources interpret groundwater results, and sometimes thinking about issues when some of these chemicals can enter people's homes from vapors getting into the basement when we have vapor intrusion. In terms of wind turbines, I think the first time that I got a call about a wind turbine was maybe 2005, and we were asked as an agency to sort of look at the question of whether or not wind turbines constituted a human health hazard. And this was from a local health department who had some residents who were concerned about a wind energy project. And so we've done a lot of work with local health departments in trying to guide them on this issue, and have the way that we consult on lots of issues, but it's been particularly contentious in certain parts of the state, particularly up in Brown County. And so we've worked with, I've done community meetings where folks are upset that the wind turbines continue to operate. One thing that I try to insert into all of my discussions on this issue is the fact that there are health concerns with lots of different energy sources, and all the ones that we deal with: nuclear, coal. There certainly are health concerns with other energy sources. That if we think about having wind as part of our energy profile, which means we're probably using less of some of the fuels or some of the sources of energy that we know have some health consequences.
Great, thanks for that introduction, Mark. And last, we have Professor Sarah Johnston. She's an assistant professor of agriculture and applied economics at UW-Madison. Her interests are in energy markets and the interaction between government policy and firm decision-making. Some of her recent work studies include the effect of energy policy on firm investment decisions in manufacturing and renewable energy. Welcome, Professor Johnston.
Hey, thanks for having me. So in my job, I interact with the wind power industry in two ways. One is some of my research focuses on that. So I'm really interested in how different policies affect these firms' decisions to invest. And so I have take data on all the wind projects in the US and try and learn something about, what makes a subsidy work better or worse for these investment. And then the other part of my job is I teach courses on environmental economics and energy economics to undergraduates. And so thinking about these different characteristics of oil and gas industries or electricity, and how they're similar to some of these other industries that we might study in economics, but also how they're unique. And one way they're unique is just energy is such a different commodity, it's seen as more of a necessity than some other types of commodities we might think about. And particularly electricity markets are, we have to have supply equal demand at all times. And so there's a lot of additional regulations and government policy that has to be involved in the market relative to some other industries. And so I think it's a really interesting industry to study.
Great. Thanks so much for that introduction. I've got a few starter questions for each panelist, and then feel free to type your questions in the Q&A, and we'll get to those after some initial discussion here. So going back to Jim, you mentioned the ability that you have to teach students how to properly design a wind farm in order to sort of mitigate the concerns around environmental issues such as wildlife issues or other issues. Can you talk a little bit more about that process for understanding and anticipating those environmental impacts and how to design and operate to minimize those impacts?
Sure. The first thing is we as engineers and developers have to follow regulations that are provided by the state. So what I mean by that is if they, excuse me, ask us to site a wind turbine 1,000 foot from a road or 1,250 foot from a residence, that's what we'll start with. We'll start with those state regulations and guidances to establish where we can put wind turbines on property. So we basically do not put them right behind somebody's house. We put them appropriately far away so we don't have to worry as much about things like noise, even though that's still an issue. And things that you probably don't even think about, like ice throw. So wind energy, the blades, we have little sensors on them. And here in Wisconsin, when they start getting coated with ice, we can use what we call power electronics to figure out, hey, my wind blade has ice on it. And we can then stop it. And actually what we do is we'll shimmy the wind turbine and try to remove that ice so that we don't launch it, so that you're not biking down the road and you get hit by a slab of ice from a wind turbine. So there's lots of engineering things that we do to make wind turbines better in the environment. Noise, ice, what we call flicker, or a kind of like a strobe, low frequency strobe light. Those are all things that we try to think about, and we design and locate the wind turbines so that they minimize their impact into the environment.
Great, thanks. And Mark, you talked about some places around Wisconsin where there've been anecdotal claims of health concerns, but the research studies that that are in the scientific literature haven't really found a connection between wind turbine noise and health. Can you talk a little bit more about those studies and what gives you assurance to kind of point to those studies to report that there's no real verifiable health risks associated with wind turbines?
Yeah, it's an interesting problem to study because many of this, when we do get complaints about usually about related to health and wind turbines, it's usually about noise and people, or noise or vibration. People reporting that they're not sleeping very well. They may have headaches, and or some general sort of stress issues. One of the challenges in looking at these sorts of effects is that they're very nonspecific. This is what the sort of symptoms that can be caused by lots of different things going on in someone's life, or other other environmental concerns. So it's tricky to study the relationship between those sorts of symptoms and wind turbines. There have the most, I think the best studies that have been done to date, the best study that's been done to date was done by Health Canada about 4 or 5 years ago, and did a cross-sectional study looking at both asking people to report their own symptoms and taking some more objective measurements of how well people were sleeping, or of noise in people's homes. And generally what they found was that there was not a relationship between wind turbine noise and health and the health effects, the symptoms that particularly the symptoms that they were keeping track of. They did find that there was a relationship between noise and people's subjective sense of annoyance. So they found that there were people who lived near wind turbines had some of those reported being annoyed by them, and that people who were annoyed by wind turbines, in fact, there was a relationship between annoyance and some of the symptoms, but the relationship between the noise itself and health and any significant health outcomes was not observed. So we've sort of been waiting for a study like this for a long time. There are lots of anecdotal reports that are in, not a lot in peer-reviewed literature, but a lot of literature that circulates. But the Health Canada study really, I think, has been the best science to date, that really offered an objective look into the relationship between wind turbine noise and human health.
Great, thanks. And then Sarah, you study sort of the investment decisions and how policy interacts with decisions on whether to build wind turbines, wind farms. Maybe going at the local level, if I'm a local leader that's considering a wind farm in my community, what are some of the economic impacts that I should be kind of paying the most attention to when making a decision if this is the right sort of thing for my community?
Sure. Yeah. So first, I guess thinking about the good from wind projects in your community. One is just lease payments for local landowners. So if you're a farmer, you can lease your land to have wind turbines and still use the land. And it's nice because it's stable income for farmers, whereas selling in agricultural markets is usually not quite as predictable in terms of income. There's also tax revenues for the community from the wind project, which is nice. In terms of jobs, the job benefits are usually just mostly during the construction phase. And so depending on the area, sometimes the construction phase, a lot of people will come from outlying areas to actually build the wind project, but often wind developers will try to use local construction labor if possible. And then in terms of the concerns, things like noise or how it affects views on the landscape, from an economist's perspective, we're typically most worried about things like if someone decides to put a wind project on their farmland, well, they're going to get the benefit in terms of the lease payments and they're making the decision, but their neighbor, might have their view affected or have this shadow or noise. So we worry about this externality, this external cost on the neighbors. But of course, there's policies like Jim was mentioning that you can put in place that try and account for that, including these setback ordinances, which how close the wind turbine can be to property lines or things like that. Of course, there's some trade-offs with that in terms of if you're really strict about that, you're probably going to get less wind development in your community. Maybe it won't pencil out for them to actually put the project there. So lots of benefits, some costs that are worth thinking about, but of course there's ways to address those.
Great, thanks. And we've got a few questions coming in, so we'll go with, and looks like some people are using the upvote feature, so yeah, feel free to use that. So right now, the one of the highest votes says, how would wind turbines being placed in every state and having them the main source of energy affect the business of nuclear, water, solar panel companies? I guess this is a question of the relative balance of wind energy versus some of these other sources.
Well, first I will say that selling energy into the grid or the transmission is pretty democratic, well, I guess we'll call it capitalistic. The person that sells the lowest price energy wholesale into the grid is what we state by state across the country use. So it really is a whoever can produce the lowest cost energy on wholesale basis is the one that's going to be asked to sell energy to the grid. So if wind energy is the lowest price tomorrow at 10 o'clock a.m., and that's what they bid, they're going to be asked to provide that energy. If a coal energy plant is not the low cost provider, they are not going to be asked to provide that energy. So really on the basis of putting these energy sources into the various states, it really is supply and demand. And I kind of want to call it the American way. The people that have the best product and the lowest prices are asked to provide that energy. I won't get into subsidies or other things that can influence that dynamic, but that's the case. And I'll just wrap up and I'll just add one thing to Sarah about the economic impacts, is that there's going to be one full-time employee per approximately about 10 or 12 turbines. So if you have a site with 100 wind turbines, you're going to have approximately a dozen full-time employees that are going to be working in the community long-term to operate and maintain those turbines.
Great, thanks. There's a question about environmental impacts. Are there technologies in the works to prevent avian collisions? Maybe Jim, if you have any thoughts on that one.
So we're going to start with proper development. So large scale wind energy sites, those that are 100 megawatts or larger, that's about the size of Quilt Block down in Darlington in Lafayette County, has to go through the Public Service Commission to make sure that environmental impacts are addressed and that there's solutions. So the very first thing with bird collisions is we're going to try not to site and build wind turbines in areas where we have a couple of things. We look at bat habitat, because we know that wind turbines that are sited near caves or other roosting areas for bats will lead to higher mortality for the bats. So it's just, if there's bats, we're probably not going to operate or build the wind turbine there. We're probably not going to put it into flyways where we know that there's heavy migration at certain times of the year. And I'll add one last thing to it. The science is evolving, but what we can do is, if we do know that there's high likelihood of birds in the area because of fall migration or spring migration, we can stop operating the wind turbines at certain types of the day to help accommodate those bird migration patterns.
Yeah, and I might add, I think the National Renewable Energy Lab studies this, and they've given out research grants for that. And there's things like radar or LiDAR that might be able to detect, when birds are near a farm and shut off as appropriate.
Yeah, it's an advancing technology. We do know from other colleagues at the University of Wisconsin, Professor Drake, as an example, that has studied raptors adjacent to wind farms. We do know that the larger birds, such as raptors, hawks, and the like, generally tend to relocate when a wind turbine farm is placed in the area. They tend to frequent the area less because whatever the biological reason is, they know that it's there and they tend to avoid it. So there other colleagues at the University of Wisconsin-Madison are doing some great research in that area.
Question from Dick asks, with some lease agreements coming to their end and renewable extensions now being addressed, Is there any information out there on the number of existing landowners that turned down the extension and the reasons for turning it down or agreeing to extending a lease?
I can start though. I guess I would only say that I think that's a super interesting question, and not that I know of. I've been looking to try and get data on wind leasing because I think it's something that's really interesting and just had not had any luck. I know that in economics, a lot of people have looked at oil and gas leases to learn something about kind of what the value of this development on people's land for things like hydraulic fracturing, but I haven't seen anything like that with wind leases.
Yeah, we have to remember that we've only had wind energy in the United States at any scale since about 2000. So a little bit older than a lot of people on this panel, probably. Our first wind energy site, large scale in Wisconsin, was down in Montfort. And the site is still operating, and a lot of those leases are about 25-year terms. And so I guess that question is going to be coming up, in the decade ahead about what percentage of people are going to want to re-up once they reach the end of those 15, 20, 25-year lease cycles.
And a question from Michael, what do you do when someone requests to place turbines? They say behind your house, but maybe near your property. Maybe what's that process for how developers come in and propose wind farms?
So it is the old-fashioned approach. So developers, including those that employ some of my students, will go to a community and they will start talking to the local officials, some of the larger landowners, and they'll sit down and have coffee. Well, not in COVID, but the development is a little bit old-fashioned, where you go out and you start making relationships, and you probably start talking to township commissioners, large landowners, because it's easier to deal with 1 or 2, 3 large landowners versus 100 different landowners. That's just the reality. And often then those farmers or large landowners will then start talking amongst themselves and band together. And that's kind of how wind energy sites going. It's a developer will come into a community and they'll start talking to both the local officials and the landowners, and it goes from there.
Maybe Mark, if you have experience, if people have concerns about a wind farm being proposed in their community, sort of what's the process for raising those concerns?
I think we get questions both from people who are current neighbors, so people who live near existing wind energy projects, and also from places like St. Croix County, where there's been a proposal and community members become concerned. So community members there may be different parts of local government that they contact, and it may often includes the local health department, and then they often consult with us in terms of what do we know about this topic, so that each local health department isn't, while to some extent they have to navigate issues like this on their own, we try to provide reports and assessments on a range of energy topics when there's a question about human health.
Great, that's helpful. Go another sort of environmental question here. Can you talk about the environmental costs of mining the resources for building wind turbines, and environmental impacts compared to solar or nuclear energy in terms of kind of the materials?
I'd love to take this one, Scott.
I figured it's right up
a great question. Well, first, if you have a iPhone or a Galaxy Note or whatever the case may be, you are using rare earth minerals in your hand. Those rare earth minerals are the exact same things that we use in wind turbines, as an example, to make magnets that control the frequency of the electricity. So yes, wind turbines do use resources. They use, the blades are made out of fiberglass or carbon composites. Those have to be manufactured somewhere. They use steel. There are environmental consequences or energy. There's embedded energy in making steel. And I think Mark said this earlier, that all energy has some negative impacts. I will put it this way. Let me just use one environmental metric that we probably all know about, and that is greenhouse gas emissions. I've done several studies and published several papers on this about wind energy in Wisconsin. A typical coal plant will use about 800, so that's 800 grams per kilowatt hour of energy produced over the life of that plant, including everything, operations, the manufacturing of the plant. Wind energy uses about 10 grams or emits 10 grams of carbon dioxide equivalents per kilowatt hour produced. So that is 2+ orders of magnitude less. Natural gas is about 60%, 40% less than coal energy. But the point is on a life cycle basis, wind energy basically hits a home run as far as impacts per produced kilowatt hour of energy.
Yeah, and I might add, in comparison, the non-emitting sources, so wind energy, solar energy, nuclear energy, in terms of greenhouse gas emissions, they're all, pretty low to minimal impact on the life cycle on greenhouse gas emissions, and much lower compared to coal and natural gas. Yeah, there are various other impacts involved with mining, especially with nuclear power and the disposal of spent fuel from nuclear power. So there's definitely other environmental concerns with that. Same thing, with solar panels. There's the materials that are used in those and the disposal of those. So different types of impacts for different types of energy sources.
And wind energy uses no water. So once you construct the plant, we're not using any water. And that is a big, big, big difference from any nuclear or fossil-based fuels that uses a lot of flow-through water and actually consumes a lot of water.
I guess there's a question about whether wind turbines are better, best way to make electricity. I don't know, maybe I might reframe this question as I like to think of different energy sources as sort of, I'll use someone else's analogy. Jesse Jenkins from Princeton likes to call it like a basketball team. So there's kind of different roles for different types of energy sources. You don't have a basketball team with just point guards. You've got the center and the forward and the guards. Wonder if maybe Sarah and Jim, if you can talk about kind of the different, how these different sources work together overall to provide energy, and do it where we're matching supply and demand at all times.
Yeah, I will start.
Sure. Sorry, my camera might be on and off. My internet connection is. Oh, either way.
Okay, I'll just do the first thing. It depends on where you are. So the wind resource and solar resource in Texas is different than it is in Wisconsin. And so in Wisconsin, I like to call it complementary resources. In Wisconsin, wind energy is very complementary to solar. And the reason is generally speaking, solar peaks in mid to late afternoon. And that's actually when wind energy in the summer particularly is at the lowest. The lowest wind speeds, lowest sustained wind speeds are typically when solar resources are the best. And then wind energy produces the most energy into the night, into the early mornings when obviously there's no sun. So that's just one example of complementary energy in a particular state. Is wind and solar are pretty complementary about when they provide their energy. Sarah, go ahead.
Yeah, I guess similarly, you know, different times of the day. Also, you can think about something like a natural gas, at least in the interim. Later, maybe we'll have storage and batteries instead. But in terms of if it's not windy or sunny, you know, we're still going to need electricity. And so you could use natural gas, or you could think about building out more electricity transmission. And so if it's not sunny one place, it's sunny somewhere else. Hydropower as well, you can think of as very often with hydropower, you need the dams do a lot of different functions. So you might use it for storage, which is great. It's very complementary to wind and solar, but also you can think about other objectives, so water supply or flood control. But just to second Scott's point, I think it's not thinking about, well, what's the one best? I think it's thinking about kind of the combination of things together. And certainly wind and solar are very promising in terms of thinking about their carbon impact relative to some of the others.
Yeah, I think where wind energy and solar energy in particular, you know, have their strengths is that they don't consume fuel. And so, you know, once you've built the plants, they run and, you know, there's some maintenance involved. But, you know, a vast majority of the costs are in, you know, building it, and then it's providing energy after that. But there are, you know, kind of the variable energy issues with wind and solar. And so that's where other sources can fill the gaps. Let's look at some more questions here. So another question is, there's a BBB rating for businesses and UL testing for products. Is there anything out there that rates wind and solar companies as to their performance? I'm not familiar. I don't know if any of you are familiar with.
Yeah, there is. So for wind energy in general, because a lot of the initial technology came from Europe, there is the International Electrotechnical Code, and that gives a lot of guidance on what type of wind turbine to build and what type of wind regime. And then more locally or statewide, especially for solar, the National Electric Code considers a lot of the performance features and the electrical circuit wiring and like. As far as solar panels, there are standards for longevity of those solar panels. So they ask people to do certain types of ASTM international test. Those are, they put them into freeze heating cycles like 100 times and see if anything degrades. So short answer to an engineer like me will geek out over this, but yes, there are standards about performance and how we ensure the electrical stability and performance of these renewable energy sources.
Yeah, and maybe to jump off that point, you know, I think there's definitely best practices when companies are coming into a community and proposing a, you know, large facility, that getting community involvement, you know, presenting, you know, being transparent about what they're doing, and getting feedback from the community and incorporating into the final design. I think, you know, that can help and sort of dispel or address some of the concerns that community members might have. There's a question about turbine blades and what do you think is the best design? Maybe I might reframe that as, we're seeing, what do we see in terms of the size of wind turbines these days? How much can they grow? What can they produce? Where do we see that going?
So hopefully everybody can see the wind turbine behind me. Maybe if you have a laptop, it's so the most efficient design is a 3-bladed system. And the reason that is the most efficient design is that because the amount of energy being produced per the energy that you have to put into making more blades, and they all weigh, and then it takes more energy to rotate that structure. We do know without question for a large wind energy turbine, a 3-blade structure is most efficient and most economical. Those are what we call wind foils. A wind foil is just like a plane wing, is that there's different pressures going over the top of the wing versus the bottom of the wing. And because we make wind energy go faster under part of the wing and slower over the other part, there's a difference in pressure. And so that's exactly what makes wind turbines turn, is differential pressure, because we make wind go faster over part of the blade versus over the other part of the blade. And I know in your competition, it's a different type of animal per se than what I'm talking about on large scale. And let's see. Yeah, so how big can they be? Everybody hopefully can picture a football field in their mind, or a soccer pitch, I guess, for the younger generation. Well, that length of a football field is about how big the diameter of our new wind turbines is. So about 120 meters or 60 meters per blade. That's about where we are right now. And then the other thing is how high they go. Right now, generally either 80 or 100 meters high. That's where the hub of the blade is, the center point of the blade. So again, almost a football field. That's how high they are. And then that's also the swept rotor diameter. And the materials that we use for the blades are ones that are light but very strong. So in material science, people are trying to develop very light, strong, stiff materials. Another area of engineering that's really really intriguing regards this this science.
Yeah, and I think especially these days, offshore wind power is maybe the next frontier, and there's potential to build really big wind turbines that can capture more consistent wind. But you also have to have those materials concerns because it's a harsher environment for those wind turbines. I think right now the standard probably wind turbine in this area is around like 3 megawatts. Is that about right? Somewhere between 2 and 3 megawatts. Oh, Jim, I think you're muted.
There we go. Last year, the average size of a new wind turbine in the United States was about 2.2 megawatts. But they can be into the 3s, they can be smaller, but across the entire country, we average about 2.2 megawatts as of last year.
All right, well, I think we'll finish with one question here. It says, when the automobile was introduced, there's a lot of resistance from the horse community. It took years, but today not so much resistance. With commercial wind and solar, they're only about 20 years old. Do you see a change in attitude for wind and solar that cars enjoy today?
Well, one of the reasons that I went out and visited all the wind farms that is in Wisconsin is when I was in a panel session like this, I could say, yes, I know how loud they are. And I'll tell you one thing is that you have to drive up pretty close to a wind turbine to be able to hear it, versus I can hear that semi coming down the road a half mile behind me. So it's all about perspective, about noise and other things. So yes, society is beginning to accept this. In Wisconsin, where only about 2.5% of our electricity comes from wind energy that's in state, versus in Iowa, that's about 35%. Iowa is way ahead of us on social acceptance because there's so many more wind projects in Iowa. There's less in Wisconsin. So while we're a state that doesn't have very many, it just takes longer for the public to get comfortable with the technology, because you only see it, I'll say it, pretty rarely. Wind turbine sites in Wisconsin are pretty rare.
And maybe Sarah and Mark, if you have any final thoughts on that question before we wrap up.
Yeah, I would say that we, in a lot of the environmental health concerns that we hear about, is when there is something big and visible and potentially noisy and new that enters someone's neighborhood. And so I think the degree to which wind turbines are increasingly not seen as a new part of the landscape, but something that is just more common in more neighborhoods, I think we'll see more acceptability.
Yeah, and I think we're moving that direction, and then also getting better at ways to mitigate noise, like turbines, to make it less noisy, or things like that are improving over time. I guess one tension that exists is a lot of these costs, well, they might not be, I guess we're saying, the research has found maybe they're not that high, but they are very much local. When we think about some of the benefits of wind, it's global. We're reducing carbon emissions, or reducing emissions from power plants, usually not in the same community as the wind development. And so I think that, yeah, there's this idea that we need communities to get acceptance, but there is always going to be a little bit of that tension where, like, for example, electricity transmission, you see it a lot. It's very complementary to renewable energy. We say, yeah, we love renewables, but then if you try and build a transmission line in someone's backyard, they usually are not too keen on the transmission project.
Yeah, so there's a way that we can kind of share, make people who are impacted share in those benefits more so. I think that's an area of that we need to look into more. So that's a great way to end. Thank you so much to our panelists for taking the time to share your insights today with our audience here. We will be monitoring, or we will be recording this session here, so we can send that out to everyone who registered, and you can share this with your friends and colleagues. So thanks for joining us. For the KidWind participants, we'll be joining in our next Zoom meeting at 4 o'clock. So see you all there.